Okay, let's go on this one here. This is video number 44, and I'm talking about the construction of a hexagon, circle math, and I'm going to propose a problem when I finish doing what I have to do, see if you can solve it. And then on Monday, I'll solve it for you. I told you in the letter this morning that you could send me an answer via email, and I know immediately if you understood what I'm doing right away. Okay, so back in the day, you'd take a compass, you'd pick a center somewhere, and you'd circle it around. I don't know if you did that in elementary school or 6th grade. You really should have. And if you had a protractor along with you, you could measure out angles. So we know that a circle has 360 degrees, right? We know that the circumference of a circle is 2 pi r. And here we're going to call r equaling 1. And I'm going to amplify that a little bit, maybe not today, but in the future. So if r equals 1, then 360 equals 2 pi. Okay? And if you want, you can put the 1 there, but 1 times any number is that number. Oh, that's kind of interesting, right? So I'm asked as maybe a 6th grader to construct a hexagon. So I'll leave this here. These ideas turn out to be really important. I'll erase the 1 there. I find it confusing. And how do you make a hexagon? Well, hexagon means 6 sides. So I take 360 and I divide it by 6, and of course you get what? 60. So to make the hexagon, I start at 0, go to 60, and count around. So you can count with me. 1, 2, 3, 4, 5, 6. Okay? 1, 2, 3, 4, 5, 6. So this will have 6 sides. Okay? So another way of looking at it is, I'll go over here and write that out, is 2 pi divided by 6, because that's the circumference. Didn't we just say that? Oh, that's interesting. So 60 degrees is also pi over 3. This ends up becoming much more important than this down the road. You should become aware of that even in 8th grade. So my task then is to, maybe with a protractor of some sort, carefully measure, and there's 60, I go another 60 and get 120, there's 180. We did a bit of work like this before when we were doing that, and let's see, so we got 60, 120, 180, 240, 300, and then 360, 0. All right? And we were doing that when we did transformations and circles and whatnot. So there we go, and now I'm going to actually make the hexagon, and I'd probably get a ruler out or something nice, especially if I care about the beauty of the object. And there we go, I'm making a nice little hexagon right here. Okay, and if I wanted to, I could erase the circle now, and out would come what we call a regular polygon, and regular means that all the sides are congruent and all the angles on the inside are congruent. That's precisely what it means. So there we go, and we also have the word regular polygon, which we'll talk about down the road, where you can make these shapes regular using circle math. You just make a circle, you identify the center, make the circle, and just rattle off the degrees as you go along, and there you go, and you have the object. All right? And I chose the hexagon because that's the easiest one. Do forgive my art. All the sides would be congruent, but it's not worth the effort to spend all that time doing it. You get the picture that if I'm carefully measuring by 60, I'm going to get what we call a regular hexagon, a class of objects in regular polygons which are created by circle math. Now, I do this because I'm foreshadowing the future over here. I'm going to erase it now, and I've put everything together here, and now I have to explain myself I'm going to make what we call the spokes, because the way I did this is I agreed to call the radius 1. That's what I agreed to do. So if this is 1, that means what? This is 1, and on, because they're like the spokes of a wheel. And why do we choose 1? Because if we know 1, we know all regular hexagons. Since by definition, all circles are similar, all regular hexagons must be similar. They only differ by a scale factor. So why not choose the easiest number that makes sense for us, and we'll say that this is 1. Okay? So now I'm going to propose a problem that leads us to what we're going to be doing. But before I do that, see the angle I'm making here? See that little thing here? I'll shade it just a little bit. That angle from the center that goes out here. It's equal to this out here. So if this is 60, then this is 60 and vice versa. All right? So that's the perimeter there. Or, as physicists and people who do serious math say, if this is pi over 3, then this is pi over 3, and vice versa, going back and forth. So now, I'm going to, so very important word, the central angle. And so now I'm going to propose a problem, and here I could make more of them. It's up to you. You think, you like to do art and stuff like that. Each triangle would be congruent that you make here. Notice there'd be 6 triangles, and the radius, of course, is 1, and the shaded area here is called the central angle. A very important concept, extremely important. And so we've done the definitions now. We know what the central angle is. We know what a regular polygon is, and we just took one of these kinds of regular polygons made by circle math, and we made a regular hexagon. So now I'm going to ask you a question that an 8th grader can do. Here, I'm fixing up the circle a little bit because I've been erasing things. See all this? Shaded area, remember we did that with a circle, and we put a square in the middle. By the way, we'd just be measuring off 0, 90, 180, 240, 360, right? You don't forget that. And I'll just shade these guys in. And I'm going to ask you that you can actually do this as an 8th grader. I want you to tell me what the ratio is of the hexagon to the circle. R equals 1. Again, R equals 1, because again, that makes it easier for us to do. So I repeat the question one more time. Your challenge task this weekend is to tell me, now let me erase all this now since I gave you some hints on how to solve the problem, is to tell me what the ratio of the white area here, the hexagon, is to the circle. And what does it obviously doesn't fill 100%. It seems like it fills much more than 50%. When we did this, we came up with 2/3 or 67%. So I'd like you to think about that as well. And I'm just leaving it like that. I don't want to give you too many more hints. And I'd like to see you send me a percentage here and tell me what is the ratio, percent-wise, between the hexagon and the circle in orders, because the hexagon is going to be less than the circle, so your percent would be less than 100%. And I'm going to round it, my answer at least, to 1/10 of a percent, and that should be pretty easy. For example, if I divide 2 by pi, and I want to know what the ratio of 2 to pi is, then I put it on the calculator, knowing that 2 is less than pi, and I divide it by pi, and up comes this number, 0.636617, on and on and on. Again, an irrational number that's been explained to you. Then this is 10th, 100th, 1,000th. We turn it into a percent, which means by definition 100th. Go 1 to the right of the to the thousandth, which we call tenth of a percent. Really important ideas that if you don't know them, you should be learning them. And I would come up with 63.7%. So 2 divided by pi, that is, what is the ratio of 2 to pi? So I think I explained what I want you to do. I'm hoping you understood me. I want you to tell me, and let me just erase all the clutter here, okay? Just to make sure the problem's clear and you understand what I'm asking you to do. And by the way, I repeat again, you may not be able to do the problem. I get that part. But don't tell me you don't understand it. That is absurd and ridiculous. Anybody understands what the problem is. The question is how to do it. So there we go. I'm going to leave it like that. I want to know what percent this is. I just want to know what this is going to be. And if I figured radius 1 out, then I know all the regular hexagons in the world. All of them inscribed in a circle because they just differ by a scale factor. That's it. Scale factor makes it bigger, shrinks it, but the ratios, by definition, must be the same. So we'll leave that as it is now. Hopefully you understand it, and this will be something that you can work on this weekend, which I'm calling a math challenge. Notice again that I needed the circle to construct the hexagon. I really needed to do that so that I could make it regular, as I mentioned. And remember, when I draw this here, so there it goes. This here is called the central angle. The central angle and the side of the circumference, the part of the circle that it covers, are considered synonymous. You know one, you know the other. You can put them in degrees, or more importantly, down the road in terms of pi. So I'll leave it like that, and let's see if anybody sends me an email telling me what that magic percent is. Okay.